Good morning, everybody. I want to talk about question 10.89 on page 611. This was the homework assignment I gave you on Thursday, February 18th. And then I wasn't there Friday because I was talking to pre-cal classes, so there was a sub. And I'm sure that you're probably not liking this problem a whole lot. So I thought I'd go ahead and do a YouTube video of it, and you can take a look at this and see if this helps you with it. Okay, this is, again, it's on page 611, number 10.89. Basically asks you to compute type 1 and type 2 errors, okay? Now I can't put the question up here, so you're going to have to open your book and take a look at it. So I'll give you a second to go ahead and get your book and open it to this page, and you can read along with me. Okay. So the question says, company makes classroom chairs for high school students, claims that the mean breaking strength of the chairs they make is 300 pounds. From years of production, they have seen that sigma is equal to 15. One of the chairs collapsed beneath a 220-pound student last week. You wonder whether the manufacturer is exaggerating about the breaking strength of their chairs. State the null and alternative hypothesis. Okay, the null hypothesis is going to be that mu is equal to 300, is what they claim. The alternate is that mu is going to be less than 300. Okay? The reason why we're doing a one-tail test, a left-tail test, is because if the breaking strength is greater than 300, we really don't care about that. The problem is if it breaks when it's not breaks less than it's supposed to. Okay? So that's why we're going to do a left-tail test. So there are the null and alternate hypothesis. Mu is going to be the breaking strength of the chairs in the population. And I probably should put mean. Their mean breaking strength of chairs in the population. Okay? So, we'll take a look at part B. Describe a type 1 error and a type 2 error in this situation. Okay, that's easy. Type 1 error is that mu really is 300 pounds, yet we reject HO and think strength is less. Okay? So there's the type 1 error. When the truth is 300, yet we've rejected this and we think the breaking strength is less than 300. A type 2 error is when mu really is less than 300, yet we fail to reject HO. So the chairs are weaker than they are advertised, but we don't accept that part of the hypothesis. Okay, they're weaker than they're supposed to be, yet we think they're okay. Now, which one's worse? I don't know. I guess it depends on your point of view. If you're the company, a type 1 error is going to be worse, because if you think the strength is less, you're going to make them stronger, even though they really are fine. Type 2 error is worse for the students because we think they're okay, yet they're not. So I guess it depends on your point of view with that. Probably the answer they want is a type 2 error is more serious from the consumer point of view. Okay, so this is part B. This is part A of the question. Part C of the question says there are 30 chairs in your classroom. N is 30. You decide to determine the breaking strength of each chair and then find the mean of those values. What values of X bar would cause you to reject HO at the 5% significance level? So as alpha is 5%, we're going to assume HO is the truth. So that means the mean breaking strength is 300. That's what we're assuming is the truth. They're asking, what is our critical value? What critical value gets us a 5% left tail? If we go through the conditions and assumptions, we find X bar is normally distributed, whose mean is 300 under the null hypothesis, whose standard deviation is 15 over square root of 30. And so all we'll do here is an inverse normal function. Inverse norm of 0.05, 300, 15 over square root of 30. And I'm going to pause this for a second. I'll get my calculator out. So there's my calculator, and my critical value looks like it's, let me put the screen up here so you can see it better. Oh, there, 295.495. So my critical value is going to be x bar star is 295.495. There's a critical value. Okay, now part D is the hard question. All right, part D is if the truth is that mu is really 270 pounds. So what they're telling us is that the truth known to the classroom chair god that knows these things, if he knows it's 270 pounds, what's the probability of making a type 2 error? Okay, now I'm going to go to a different screen and do a little setup here. So it's just going to flash on here in just a second. It'll be like magic. Okay, poof, there it is. Here's what I had before. This is the distribution of the null hypothesis, if that's the truth. Okay, here are my hypotheses. My n is equal to 30. My sigma is equal to 15. All right? What they told us, and I'm going to write this in red, is that the truth is that mu is equal to 270. Okay? What that means is that the truth and the distribution of x bar is going to be over here, like that. That should be centered. Okay? This is the real distribution of x bar. It's not what we assumed was true. Okay? Making a type 2 error means that we are going to not reject the null hypothesis, even though the truth is the alternate. Okay? So what we need to find is this area right here. Because if our sample mean is to the right of our critical value, we will create a type 2 error. Okay? So we can take a look at it. What's this probability? All right, well that's going to be a normal CDF function. Let me write the probability statement in black. So this is what you would write. Probability that x bar is greater than 295.495, and this is if mu is equal to 270. Let's not forget that. Okay, normal CDF of 295.495, big number, 270, and 15 over square root of 30. Okay? And you can see from my calculator here that this probability is extremely low, 6.5 times 10 to the negative 21st. Okay? So what that means is that this probability here is basically 0. Okay? What that means is the probability of making this error of accepting the null hypothesis when the null hypothesis is false is just not going to happen. Which means if the true mean is 270, we have almost certainly a certain chance of correctly rejecting the null hypothesis. So what does that say about the power of this test? Go ahead, what do you think? Power of this test is really, really good, isn't it? Which means if this is the truth, we are almost definitely going to reject the null hypothesis and make the correct decision. So there's the homework problem for you. Hope that helped.